Yeah, I understand I'm between you and your lunch right now. But thank you. Thanks for hanging in there. I'd like to talk today about the impact of cloud in the telecoms environment. Now, I know this might sound like a bit arbitrary for many of you that are so close to the fiber world, but I think many of you would have heard in the news recently about the DDoS attacks taking out a number of ISPs and the like. I think increasingly becoming relevant is the question of, is the internet the same thing to everyone? In fact, quality and latency and performance is becoming a key issue. More so because of the advent of cloud adoption. So before I start talking, can I just get you guys a little bit involved? How many of you in the audience feel positive about the telecoms environment right now? Many of you that are in the business, in the trade, feeling positive about it. Okay, all right, that's a good show of hands. How many of you are worried and concerned that maybe what we do in the telecom space is beginning to slow down a bit? Okay, less show of hands. So overarchingly more positive crowd here today. Well, that's fantastic. It's going to make my job a bit easier. So when one of the things that worries me, though, related to the topic that we're about to speak about, is system integrators. The guys that used to ship desktops, they used to ship routers and Ethernet switches and server hardware and those sorts of things. There's a notable decline in the amount of hardware that they're shipping. And that's really, just to give you a very direct correlation, that's really got to do with cloud adoption. The more cloud is being adopted by customers out there, the enterprise customers out there, the less boxes are being shipped. And I guess today we'll talk about the quality of the internet and ultimately what happens downstream, because if it's hitting the system integrators today, it's going to ultimately hit us as telecoms providers in some time to come. And hopefully it'll be long, but I suspect it might be a bit shorter. Okay, so let's go back in time, right? So when many of us were at university or in our first job, when we think of IT, this is kind of what comes to mind. I might have worked in one of these environments myself. And when you think of IT as the kind of place where you have this IT guy that runs around the office, and he runs two sets of cables, one's for the phones and another for the desktops, right? And all of this put into a computer room, where he's got a rack with a battery and a UPS keeping everything alive. Those cables run to the PBX, and then there's a server sitting on top of that battery as well. Within that computer, he's got an operating system loaded with Exchange, and that's it. That was kind of like the basic heart of IT. Of course, with time, somebody loaded ERP onto it, and so you ran your financial system predominantly, and that ERP system grew into many of your business processes. What was awesome, though, was you could access any of this when you were in the office. Right, so you didn't really need a laptop, and you're quite happy not having one. And when you got excited about getting a laptop, you probably should have been the first warning, because with that laptop came the VPN, and then you were able to tunnel it into your office network and get access to these systems that you historically wouldn't. Now, security wasn't too much of an issue, because your IT guy was really running his network in an isolated manner. And that was what security was all about. When we move into the cloud environment, and especially when your network is connected to the internet, security becomes so much more complex, and so does your architecture. And that's ultimately where we're going today. So when us old folks seem to think of IT moving into the cloud, we get very excited about our OpEx coming down, spend going down, and all this IT stuff that we didn't understand, kind of, being less of a bother. We seem to think that it's going to go into this pretty little cloud. And when we try to dig past that pretty picture, and we try to imagine what it would look like, we come up with this kind of image. So in the cloud somewhere, there's going to be some kind of server application that has some kind of gateway that I connect in from my office, and that too is connected to the internet. So we tend to think of it quite simplistically. Right? So at this point, I want to introduce the concept of the virtual private cloud, or regions. So whether you deal with AWS, Google, or Amazon for that matter, when you buy services from them, you're buying it actually in a specific region. And many of us don't realize that, but you buy it in Ireland, and then you buy it in east coast of the US, and so forth. And that's important for later in this presentation. In practice, though, we're not just moving one office. We're moving a far complex networking environment which your IT guy is running. And it may involve the head office. It'll involve a couple of regional offices. Regional offices not just around the country, but maybe offshore as well. And of course, remote users that are working from home. So the IT networking environment practically is a lot more complex. And now you've got to get it to move into the pretty cloud. And how does he do that? So this is where, the journey for me gets quite interesting, because when I try to unravel this, being a bit of a strategy guy and, I every now and again go and try and get myself trained up on the latest tech. It's a bit of a struggle for an old brain like myself as well, but this was a bit of a shocker for me. And I'm going to take you on my shock journey. So when you move that multi-site environment into the cloud, you're beginning to get a far more complex environment, right? So the whole reason you ran those different regions was not just because of offices. Sometimes you ran your own backup data between two different offices. They were just supporting each other. So now you move that into the cloud. You've got two application servers. You've got two gateways. Somehow they connect into the internet. And you've got your multiple premises connecting into this. But how do these servers actually connect to each other, especially if they're in two different regions, right? So something's kind of missing in between. And so what I discovered was actually the connectivity between regions is actually, in fact, provided to you by an Amazon or Google or a Microsoft, for that matter. So they're beginning to become your telecoms provider as well. So your cloud provider is just as well your telecoms provider. So when you were running that 10 gig backbone between Johannesburg and Cape Town, as an example, because you were backing up your servers at night, or running synchronization, or shifting workloads, you're not doing that on your WAN anymore. That's being done by AWS and Microsoft for you. Also, let's say what you were running there was a customer front end that was accessible via the internet, and the customer logged on and he filled out a form, and that form went onto maybe an automatic contract, accepted the quote dynamically on a web interface. That public IP address, which is your web interface, guess who sells you that public IP address? Google does, or Amazon for that matter, or Microsoft. So they're more than just the telecoms provider, they're kind of your ISP as well. I guess we've always known that it was a convergent environment. So let's pause there for a minute and then think about the bigger picture and where cloud is ultimately going to, 5 years and potentially 10 years. This is some really interesting research, which I'm going to have to look very closely at the tiny writing here, by Deloitte. And if you can read the text on the top left-hand side there, typically what CIOs today are thinking about the cloud is like, okay, we know it's coming, we can see it happening in the rest of the world and those sorts of things. I'm going to experiment with it. And so, it's kind of like my development and my non-mission critical applications, I'm moving that first into the cloud. So that's the biggest bar on the graph on the top left-hand side. But what does he think he's going to be doing with it in the future? And then what you see is those things that he's keeping to himself right now, mission-critical applications and mission-critical infrastructure, the stuff that he's not letting go today. He's beginning to envision that in a matter of years, he's going to let that go, and he's going to let that move into the cloud as well. So in that environment, with all of that telecoms and all of that IT moving into the cloud, and if you're going to start moving your mission-critical applications and so forth, then your kind of your telecoms provider, your networking across your private network as well as your cloud environment becomes very, very important. And why is the cloud important just generally? It's because it introduces a new way of conducting operating models, business operating models and so forth. And I think we've all seen it, you think about how Uber's disintermediated. I know, it's the common examples that everybody uses, right? But more so, if you think of Pinterest, great example. It's a bit of a social community for sort of arty folk and people interested in decorations and those sorts of things. Do you know the entire Pinterest application does not exist on any server except to be on AWS? They've built an entire model in the cloud. And I think some more local examples of that is Time Bank, which is a great story, where they've built the entire banking system in a cloud platform, been able to launch a bank and get 1 million customers in less than 12 months, which is an outstanding story. With no legacy, and embracing compute as you need it and storage as you need it and so forth, many new operating models have evolved. What I find fascinating is the AWS's term called democratizing artificial intelligence. Now, we've all known that AI has been coming for many years now. But typically, if you went to an IBM, a couple of years ago, IBM's changed the model today, but if you went to IBM a couple of years ago, they would say, yes, you can have Watson, but it's going to cost you like $5 to $10 million to get your version of Watson enabled to you. You go to AWS today, for a couple of dollars a month, you get your version of AI available to you to start developing and training, right? So this is a boon for many of us, especially us as Africans that are trying to leapfrog or leap forward in the market and try to take on Silicon Valley. What we need is an idea, very little capital available to us. We're able to access technology that we couldn't before to take our ideas to market. So it is a huge opportunity for us. But with that comes tremendous pressure downstream. It's going to change the way that we as telecoms and ISPs operate as well. So I'd like to introduce another layer of complexity. If this was already complex enough, what typically happens for some of you in the audience that may be CIOs, right? Now, when all of your infrastructure is on site, you get to choose, I want this ERP, and I want that mail system, and I want that CRM, and so forth. So you kind of choose the best of breed for the purpose that you do, and you build your applications in between. Now, very similarly, there's a great case of one of the largest banks in South Africa. They've been running a general ledger on a specific application that they bought 25 years ago. It works so well that they just don't feel the need or the risk to move off of this. So why would you move that into the cloud? You might run some analytics on that general ledger in the cloud, but you wouldn't necessarily want to move that, right? So what I'm saying is that it's very likely that your future cloud environments or your customers' future cloud environments will be a mix of Google, it'll be a mix of AWS, as well as Azure. And if that's not complicated enough, Office 365 is not Azure. It's a different type of cloud application. So all of your desktop applications are moving into the cloud, and they work in a very different cloud environment. We've seen our customers that move to Office 365 triple their bandwidth demands. So that's great. I mean, there's a bit of a future revenue sale for us there. But your bandwidth demand triples going into that. So now, the idea of subnets is important. So some of you that have come from a networking background, you know that you have your internet gateway, and you run all of your different offices on different subnets. And those computers have a private IP address that you're allocating to it. The complexity is so much so that you will have a subnet for your local office. You'll have a subnet that you'll assign to Microsoft, and another one to AWS, and another one to Google. And all those virtual servers and all those applications are running on your private IP address range behind your networking architecture. So you are undoubtedly getting into a complicated world of networking in this multi-cloud environment. So how do you connect into the cloud? And that's kind of what we do as telecoms companies. There's these four options, right? It's just either layer 3 or layer 2, either on a dedicated basis or on a shared basis. So you can go to Terraco as an example, and if you're a large enough organization, set up your own private peering connection, a layer 3 peering connection, the way that telcos peer with each other. You can set that up and peer with Microsoft. Of course, Microsoft will not, because it's layer 3, not offer you any SLA with that. However, if you did that, if you had a dedicated connection to Microsoft on the layer 2, you'd get they'll stand by that connection, right? And that's really because of the congestion that's coming into the routing network. You can also rely on a partner. You can, peer on a shared basis into one of your cloud providers. Or you could even share a dedicated layer 2 connection into any one of the cloud providers as well. But most of all, though, whilst all of this is available, what most of us do is we VPN into the cloud. So if you've got you've got an application that sits on your router that VPNs in, or you've got a secure browser that VPNs in, and so forth. So typically, we're relying on the public internet and encryption to get in there. And now this is where it gets really messy for us. Now, with my opening statements, I think we've all seen the DDoS attacks becoming more prevalent in Africa, in South Africa more notably, just in the last 4 weeks. And so the quality of the internet that you got coming to your office environment becomes materially important, especially if you're planning to VPN into your cloud provider. And then it's here that I'd like to bring it back in sort of the telecoms world. So not all internet is the same. And what I've got represented up here is just two architectures that many of us will be familiar with, kind of a flat layer 2 architecture on both sides. And up front, I want to tell you, as Seacom, we make both of these available to our customer base. It depends on what price you're willing to pay and what your expectations are. We make both of these available to our customer base. So we do run a flat layer 2 architecture for our broadband customers. Now, those are typically home users or SMEs, low ARPU kind of clientele. We bring them in on flat layer 2, we take them up to a radio server, and they connect them to the internet. And as you can see from the architecture, it's pretty simple. It has a degree of redundancy into it, but it all relies on aggregation up into that router, and then from there breaking out into the internet. Now, the telco-grade, enterprise-grade architecture on the right-hand side is a far complex routing network. Now, we run this as well. It's a bit more expensive because you're spending a bit more on hardware. You're meshing your network in a city, sometimes even in a suburb. You're running mesh. And what happens here is you can see that all the customers aggregate onto the closest routing point and has a mesh of multiple paths to get out into multiple points into the internet. So the point being is on the right-hand side, if you have a DDoS attack, when someone's trying to flood your network, it's pretty difficult to achieve that on the right-hand side, especially if you're running hundreds of gigabits like a Seacom does, or we run terabits, in fact. It's pretty difficult to pull that off on a terabit network. If you got one aggregation point, like on the left-hand side, getting onto the router, and you're running just a gig on that, a gig's pretty easy to burn through for a DDoS attack. And that's what's affecting the quality of service downstream. In fact, some of us are seeing it on our home connections as well. A lot of the GPON networks just come up to a signal aggregation point, and around 6 o'clock, even if you've got fiber into your home and you're running on one of the GPON providers, you can see a bit of slowdown in your network performance. So with that in mind, to many of you that are servicing the enterprise customer base, or you're an enterprise customer yourself, I'd like to bring this to a conclusion. And I think you can see why, now understanding what happens at the telco infrastructure layer, why cloud providers tend to steer towards a private connection, a dedicated connection. And whilst I think VPN is a workable solution, I encourage you to think deeply about your telecoms provider and the quality of the underlying network that you are going to move all of your operations onto. Because these days, when you move your IT off-site, you're moving it into the cloud, you're actually moving the heart of your operations into the cloud. And even for other workloads in the public space like Office 365, you need a proper internet connection that can support that migration. And more so, when you're contemplating the complexity of all this, choose the partner that can take you on that journey comfortably. So thank you. Enjoy your lunch.